Jai Shri Manaran kids. Okay, today we'll discuss the 24th January shift 1 physics JEE Mains 2026. I think the paper little bit very easy compared to the 23rd both the papers. This is the moderate paper we can call, not easy, not tough, moderate paper. The physics moderate, is a moderate. Chemistry easy. Maths moderate and lengthy. I think this is a typical our J mains like a question paper based on the PYQs. When you solve the PYQ book, no, the similar type of all questions we have come across. And the physics, it was like a moderate paper, not like yesterday's physics paper. It was really, really very useful for students. Those who are very good with the concepts and formulas, they're able to do it. Once again, my general request to all the students who are writing 28 shift, stick on to the formulas and concepts. Definitely you can manage very easily the paper. No need to be panic. Formulas, concepts. Anyway, you have time. If you want to solve few PYQs. Right? So don't bother like 23rd one because I think two papers came. So definitely again, so many papers getting repeated, high level, highly impossible. So stick on to the basics thing. So the physics expected 28, there's a 24. The 28 also, both the shifts will be of this kind only. Or maybe easy to moderate or moderate. Okay then. Now we'll start with the marks and percentile. This is 94 marks is giving 92 percentile. 106 marks, 94 percentile. 125 marks, 95 percentile. 143, 96 percentile. The threshold everyone which you target, 160 marks is coming around 98 percentile, or it may be up to 150 marks. And these two things, little bit data what we have gathered. So we can put plus or minus, so plus or minus 5 or plus or minus 10. So 150 marks will be 98 percentile. And 175 marks will be 99 percentile. This is the typical today's paper. I think it's a nominal paper, the routine paper, what we had. And 150 marks will be 98 percentile. Okay, fine. So I think today's paper, lot of students done very well because of this moderate levels. Okay, we'll take the weightage. Again, if you look at the mechanics, no, only 7 questions. I think the past few shifts, the mechanics, its weightage is coming down like anything. Earlier it used to be 10, minimum 10, no, now it is coming to 6, 7. So past 4 shifts, this is what happening, mechanics. Less number of questions coming from here. LCD maximum, this shift 7 highest till now. Maximum it was 6, now here it asks 7. Modern physics, including semiconductors, this is 4. What all mechanics like? They've asked the viscosity, surface tension, projectile motion, laws of motion, work power energy. One problem on the SHM fluids, this one. LCD maximum, electrostatics 2, capacitor 1, current density, then electromaximum, electromagnetic induction, and AC circuits, and EM waves. Modern physics, atoms, photoelectric effect, semiconductors, matter waves. I think this photo, and nuclear physics. Optics, one question on prism. I think this year only the prism, there's a 4th question which is coming for prism. I think earlier only 14 questions came. This January only there's a 4th time they are asking. So most neglected topic prisms, they started asking now. So those who are writing 28 shift, better revise prism also. Very few questions are there PYQ, only 14 questions are there. But there's a 4th time I'm seeing prism question. So the most neglected topic now has become very important in this January session. So one who are writing 28, no, please do revise some prism things. Then one optical instrument. Question they've asked: optical instrument, one on the lens, one on the, so like a refraction at plane surface, optical instrument and prism. Thermal physics, thermal expansion, and the KTG thermodynamics. Waves and sound 0. Experimental 1 question. This is the typical our the weightage of the physics. I can't tell about anything about the chemistry, maths. I don't have much idea about the other subjects. Only the physics is what I can give this weightage. Okay, now afterwards, physics type of questions. Again, five questions formula based, 13 question formula based, 18 questions here. Again, see once again, this is the thing which will decide your rank. The formulas. This paper also purely revolves around the formulas. In objective, there are 13 questions are there which are based on formulas. So definitely, I think those who are writing 28 shift, you have to revise concepts and formulas. Short 15 questions minimum, maximum 20. You can manage with that idea. Next, objective derivation. This based on conceptual. There's no any conceptual question. Match the following two very easily. Reasoning 1. This is the rank decider for those who are writing 28 shift. Please do focus, and 24th second shift also. This is the area which you have to improve it. So how to prepare for this one? Revise all concepts and formulas. Suppose you picked up 20 chapters. For all the 20 chapters, related formulas and concepts recollect. Now you'll be on safer side. Okay, this is overall about the paper analysis. Now we'll get into the paper discussion. Okay, I think most of the students will be relaxed, especially those who are writing 28 shift. You not to be in panic. You can manage very easily. Just focus on this area of the physics of formula based. These papers are formula based. H-ray, this was 7 questions. This was 5. This was less. So when paper is not formula based, physics will become difficult. This is what the methodology is, what is happening. Well, I'll start the paper discussion. Now we'll begin with this. There's a question based on the friction, 3-block friction. So don't get scared. Some simple concept is there. Figure shows 3 blocks with masses 8 kg, 6 kg, 4 kg. Friction coefficient between each surface is 1/2. At all surfaces. Find the maximum value of force such that 8 kg block moves with constant velocity will be. This should move with a constant velocity. What is the basic method for this? Here it will be string will become taut. Friction will act here. F3 and string will become taut. This will be tension. Then what is the tendency? This 8 kg block will be moving towards left. So this length of the string will increase. This length of the string will decrease as it decreases. So definitely what do we expect here now? These two will move together. These two will move together and it's going to move. So the 6 kg block will be moving towards right. So the friction will be acting on the block in this direction. Okay, now. F2. Here F2. Here F1. Here F1. What is F3? F3 is equal to mu into sum of all 4 plus 6 plus 8. G. Mu is 1/2. 10, 18 into 10. 9990 Newton. F2. The coefficient of friction here, this friction depends on this normal reaction. The normal reaction here will be equal to the weight of all three blocks. Okay, that's why I'm writing it. Time will not be there. Next, the friction acting on this between 6 kg and 8 kg block depends on this normal contact. This normal contact depends on weight of these 2 kg blocks. The weight of these two blocks. So mu into 4 plus 6 into G. 1 by 2, 10 into 10. U into 4G. The friction acting on between 4 kg and 6 kg depends upon the normal reaction on the 4 kg block. And normal reaction 4 kg block will balance the weight of the 4 kg block. So we are writing mu 4G. This will become 1 by 2, 4 into 10, 20 Newton. Tension T is equal to F1 plus F2. Yeah, we look at this one. As this has to move with a constant velocity, net force on this should be 0. So this applied force F will be balanced by this friction F2, tension and F3. And this tension, this F1 will become internal force. Okay, together you can take this as system. Tension and here F1 and F2. These are the forces acting. So we'll now what about the tension? The tension here will balance this F1 plus F2. Or will you go for only the this tension? So here this tension what happen? Will you take F1 plus F2 or it should be only F2? Because together no slipping should occur. So together they should move with a common velocity. So for this to happen, then this tension T plus F1, F1, F2. So T will become equal to only F2. Because 4 kg, 6 kg will move together. Okay, agreed? Huh? Okay, now individual. Like, or we'll do one thing. This will move towards right. This will move towards right. So the tension here acting should be equal to these two will move together. T should be equal to only F2. I'll erase this. This will be. We'll come to the idea like this. On 8 kg, it should become F should be equal to F2 plus T plus F3. F2 is how much? 50. Tension we don't know. F3 is 20. This is F on 6 kg and 4 kg block. Together we have to take the system, these two. This should be equal to T plus F1 is equal to F1 plus F2. So T equal to F2. F2 will be 50 Newton. So F equal to 7 T plus 50, 120 Newton. Something, it should be 120. Okay. Some correction will be there. So memory based, no. So this is based on friction. No, this is a problem based on electrostatics. Three uniformly charged concentric shells are kept as shown. Charges on individual shells are as shown. Find the potential on each cell. They are thin shells. So charge on shell is Q1. Here charge is Q2. Here charge is Q3. We have to calculate the right equation for potential. Don't look at the option and get scared. Potential on the shell A. We'll write equation itself. Potential on the shell A will be KQ1A KQ2B plus KQ3C. You need not to bother induced charges. Don't show induced charges. For thin shells, whether you consider induced charges or not, answer will be same. What is the basic idea for thin shells? Induced charges need not to be shown. Whether you consider or not also, the answer will be same because the net charge will be considered. Okay, now, similarly, potential at shell A. First only due to shell A, KQ1 by A. Then shell A and shell C are removed, KQ2 by B. Shell A and B are removed, KQ2 by KQ3 by C. KQ1 by B, KQ2 by B, KQ2 by C. I'll explain. Okay, this one. Sir, how you are writing. First, only due to the, you are here, due to the shell A, KQ1 by B. Due to shell B, KQ2 by B. Now, remove shell A and B. This point is there inside the shell C, KQ2 by C. Now, we'll find out potential due to shell C. KQ1 by C, KQ2 by C, KQ3 by C. It will satisfy this one. Okay, these are based on the laws of motion, rotational motion. Problem based on there's a block 400 gram, here 350 gram radius. The blocks move 81 centimeters 9 seconds. Find the moment of inertia of the pulley. First, we have to calculate the acceleration. Moment of inertia, the pulley definitely will have the mass 81 centimeter in 9 seconds. 81 centimeter, 0.18 meter in 9 seconds. Will get the acceleration. Now, what is the basic idea? Now the weight of this 350, 0.35 kg will act, 0.4 kg will act. Here tensions will be different. Here radius will be there. Torque is set up and it starts rotating. I'll start with the free body diagram. Here the tension T2. Here the tension T1. Weight M1G. This M2G. This will accelerate like this. And it will rotate. This tension will be greater than this, so net torque will be clockwise. So it will be rotating clockwise. R and R. We have to calculate this moment of inertia. Okay, now we'll write down the equations. This will be, before that, what is the acceleration? It will undergo displacement how much? L. L equal to A T square by 2. L is equal to how much? 0.81 A by 2. T square 9 square. A is equal to 0.02 meter per second square. This is the acceleration of the blocks. Huh? Now we'll write down the equation. m1g minus t1 equal to m1a. 0.4 into 10 minus t1 or 4 minus t1 equal to 0.48. Similarly, t2 minus m2g equal to m2a. t2 minus 0.35 into 10 3.5 0.35. We know value of a. Then on the disk, T1R minus T2R equal to I naught alpha. T1 equal to 4 minus 0.48 minus T2 will be moment of inertia. I naught equal to alpha equal to A by R square. This R and this R is adjusted. This R and alpha equal to A equal to R alpha. Alpha equal to A by R. Look at this one. So we know all the values. Solving for this, we'll get the I naught. Lengthy calculations. Okay, fine. Now, sir, what is alpha equal to? Alpha equal to A by R. This R is sent to the denominator. Now we know value of A, 0.02. Substituting, solving for this, we'll get the value of I naught. Based on fluids SHM. A cylindrical body of mass m and cross section A is floating in a liquid such that it acts vertically. If body is displaced by small displacement vertically, find the time period of oscillations of the body. So initially it's in equilibrium. At equilibrium, H, cylindrical body, weight mg will act, buoyant force Fb naught, some H length is immersed. So then this will become H x new buoyant force and it will accelerate. Density of liquid is rho L. So now initially it's in equilibrium. Some H length is immersed. When you press it, the length immersed will increase. And because of this, what will happen now? The buoyant force will increase here. The buoyant force will be greater than mg and it will accelerate up. So initially, buoyant force equal to mg. What is the buoyant force equal to? Density, volume immersed, AHG equal to mg. Initially at rest or equilibrium. Now, when you press it slightly, this extra length will be immersed. This extra length is what the restoring force. So buoyant force will be greater than mg, so therefore it will accelerate up and it will be oscillating up and down like this. Then here we'll write the equation ma equal to fb minus mg. What is the buoyant force? Rho L A new buoyant force minus mg. A is equal to rho A H L will cancel out. Ma equal to rho L A Gx. A is equal to negative sign because acceleration opposite to displacement. So rho L A G x by m. Comparing with standard equation of SHM, omega square equal to rho LAG by M. Time period will be M by rho LAG. Based on fluid statics and SHM. This based on the semiconductor. Zener diode of breakdown voltage 10 volt is connected to an external voltage 15 volt, and the resistance frequency power of Zener diode is 0. Find the value of unknown resistance. Okay, now given circuit, we should draw the circuit also. This is a cell, series resistance, Zener diode. This resistance R we have to calculate. External voltage Vs 15 volt, Zener diode Vz 10 volt, plus minus. A current of high will flow. We have to calculate the resistance of this one. There is no load resistance connected. Let it be. What is telling now? Power of Zener diode. So we have to take help of this 0.4 watt, the power of Zener diode. So we know what is the expression for power. Power, how you define power of the Zener diode, equal to Vz into Iz, 0.4. Vz given 15, we'll get Iz. Iz equal to 0.4 by breakdown voltage 10. This is 10. $40 milliampere. Then we'll write down the equation. Vs minus Izr minus Vz equal to 0. 15 Iz value (0.04). R value we don't know. Vz is 10. (125 ohm). A very strange question where no load resistance to confuse you. Usually we'll have the year one resistor RL not there to confuse you. We'll take the next one. This based on the kinematics, projectile motion. A projectile is projected with certain speed at an angle of 45 degree. Here speed u at an angle 45 degree with horizontal as shown. At t equal 2 seconds, projectile is at maximum height. And at t equal 3 seconds, it just touches a wall at a height h or just grazes here. Above horizontal, find h meter. We have to calculate the height of this wall. Okay, now at t equal 2 seconds, it is here. So what is the velocity here? U cos theta. So half of the time of flight, t by 2. Okay, I'll write it in simple way. We know time of flight equal to 2u sine theta by g. T equal 2 seconds will be here. T equal to 4 seconds, it will be here. If it takes 2 seconds to move from point of projection to highest point, from highest point to point of striking will be 2 seconds. So total will be 2 plus 2, 4. Okay, this we know 2, u we don't know, sine 45, 1 by root 2, this is 10. U is equal to 20 root 2 meter per second. This is the initial velocity of projection. Next we have to calculate this height. H is equal to u sine theta t minus gt square. Applying equations of motion from here to here along y-axis. When it moves from here to here, what is the height it will ascend? H. And how you measure the displacement? Along u sine theta. And how g is acting? G is acting opposite to this. Here we will indicate these values. U cos theta, u sine theta. U sine theta, H is in the direction of u sine theta, so H positive. G is opposite u sine theta, that's why here negative. Substitute all the values. This will be 20 root 2, 1 by root 2, 3 minus 10 by 2, 3 square. 60 minus 5 into 9. H equal to 15 meter. Easily manageable. 3 masses M1, M2 and M3 kept at vertex of an equilateral triangle of side. If masses are shifted to new configuration such that they are at the vertex of an equilateral triangle of 25, find the work done in the process. Okay, this manageable. Such questions students should initial potential energy, final potential energy. What is the work done? Work done is equal to work done by external agent equal to change in potential energy U2 minus U1. Masses are different, so U2 will be minus 3 G M1 M2 by, call this is L2, this length as L1. You can L2 minus G M1 M3 L2 minus G M2 M3 L2 minus of solving. We'll get the, I think you have to go for really very easy simplifications method. GL1 M1 M2. How you save time in calculations matters a lot. M1 M3 M2 M3 M1 M3 plus M2 M3 minus of GL2 M1 M2 plus M1 M3 plus M2 M3. Now take this also common. Okay, everyone getting some idea how to G also you can take common. This will be plus. This will become 1 by L1 minus 1 by L2. Now you substitute the values. You should not do calculations here, very lengthy. Simplify. Now you put it. They're very rare. He wanted you to think like this. Now substitute these values. Will be easy, no? Value of G will be 10 to the power of minus 11. Now you have to verify the key. I'm not having the key. Only question is there. This is M2, M3. Based on gravitation, it is. Next one. Figure shows a meter bridge. Initially, null point was achieved at point P as shown in figure. When an unknown resistance R is connected in parallel with 3 ohm, the null point was shifted by 22.5, then the value of unknown resistance is. Two diagrams, sir. Initially, what is the null point? The initial null point, where it is at point P. Call this is L. Now you are going to connect a this is L2. This is L1, you write. This is L2, 2 ohm, 3 ohm, unknown resistor R. Then the value of unknown resistance is asking. Null point is shifted by 22. Will it shift towards right or towards left? Definitely towards right. L2 will be greater than L1. So L2 is equal to L1 plus 22.5. Current through galvanometer will be same. So therefore now 2 by 3 equal to L by L1 by 100 minus L1. Afterwards it will be 2 by 3R by 3 plus R is equal to L2 by 100 minus L2. Substitute all the values. Now what we have to do is like L2, what you can write? L1 plus 22.5. 2 by 3R okay, now L2 also, this will be L1 22.5. A little bit calculations are there, manageable. How many unknowns are there? 2 equations, 2 unknown. Solving this will get the required answer. Now first we'll calculate L1 from here. So what about L1? L1 equal to how much? Better if you know L1, it will be very easier. This will become 200 minus 2L1 equal to 3L1. 200 equal to 5L1. L1 equal to 40. Substitute L1 equal to 40. We'll get the value of R. Based on the current density. Two resistors of resistance R1 and R2 are connected in series. A voltmeter resistance 400 ohm is connected in parallel to one of the resistance. Find the reading of voltmeter, the EMF of the battery. Or the voltmeter resistance how much? 400 ohm. So here you bring the 400 volt. Now 400 ohm parallel to 300 ohm. So the effective will be, we have to calculate, will be 400 into 100 by 400 plus 100. 400 by 5 will be 20. 500, 80, sorry, 80 ohm. This will be 80 ohm. This will be as usual 100 ohm. And this is cell. What calculations I'm doing? Here, look at this one. 400 ohm parallel to 100 ohm. The effective will become 80 ohm. Because parallel, no? 80 ohm. So here's what the voltmeter is connected. This drop across this will be the reading of voltmeter. We have to calculate this one. So V naught equal to now 9 into 80 by 100 plus 80. 9 into 80 by 180. 9 into 4 by 9. 4 volt. V naught, this one, reading of voltmeter. This will be 4. So, but where is voltmeter? The voltmeter and this under together will replace with 80 ohm. And what is the drop here? That will be the reading of voltmeter. Okay, fine. The 4 volt, if you want, I'll show it here also. And this based on current LCT voltmeter concept. Next one. Electric potential at point is defined by this equation. Find the charge enclosed in a sphere of radius 1 meter centered at r equals 0. What we do is like we'll calculate the from the electric potential we should calculate the electric field. So here the charge enclosed in the sphere of radius 1 meter. How much of charge is enclosed? V equal to A r cube plus B. Differentiating this, dV equal to 3A r square plus 0. dV by dr equal to 3r square. So equal to minus dV by dr. So first what we'll do, we'll assume a thin shell. Thin shell. Radius of this, let radius be capital R. I'll assume a thin shell of radius smaller. First we'll calculate how much of charge in this, then we'll integrate. So this will become, formula will be flux equal to E bar dot ds q in by epsilon naught. E is equal to 3a r square. ds will become E is variable, no? We have to calculate the total charge. Surface, this will become 4 pi r square. Is this will become only this much. Substituting the values here. So here it will be r equal to how much? R equal to 1. So this will become 12 a. Okay, this I'll rewrite. This will become 12 pi a r to power of 4 q in by epsilon naught. R equal to r 1 meter. 12 pi epsilon naught a. This will be pi will be there here. Okay, we'll take the next one. And this based on the Gauss law, electrostatics. Next one, problem based on AC circuit. Figure shows circuit consisting of capacitor, inductor, and resistor connected in series with an AC source. Find the power factor of the circuit. We have to directly get the power factor of the circuit. What is the formula? Now, here this will be R, this will be XL, this will be XC. So the resultant will be R this will be Z. We'll calculate XL and XC values. Directly they given this is XC, R value, XL value. So what is impedance Z equal to R square plus R square 60 square 150 XC minus XL or XL minus XC, both are same. Okay, this is a value. AC circuits. Next again, based on the ray optics, light is incident at such an angle so that minimum deviation takes place. Now a film of refractive index is stick on other face such that total interference takes place on the second surface. Find the angle of prism. Minimum deviation occurs. So light. This problem is based on the minimum deviation condition. What we have to do with the help of minimum deviation? First, we have to bring the prism. In this prism, a minimum deviation will take place. Light is incident. Find the angle of prism. We have to calculate the angle of prism. Now we know this angle will be I, R1, R2, and this is I2. Same diagram, what is telling? Total internal reflection will take place. R1, R2, this is A. This angle is what? I. This angle will be 90 degrees. Now this is N. This medium will be N by 2. So sin R2 equal to 1 by 2. R2 is equal to 30 degrees. If R2 equal to 30 degrees, then what is A equal to? A equal to R1 plus R2, and at minimum deviation R1 equal to R2. So A equal to 2R1. So A equal to 2 into 30, 60 degrees. You have to take help of this diagram and this diagram. This based on prisms, ray optics. I think only this session they have asked more prism problems. Huh? Terminal velocity of drop radius is 10 centimeter. 64 such balls are combined to make a large drop. Find the terminal velocity of this larger drop. What is the expression for terminal velocity? R, like this, how many? 64 are there. 64 balls. The mass will be conserved. Mass will be, this will become rho into 4 by 3 pi r cube. 64 rho into 64, 4 by 3 pi r cube. R cube is equal to 64 into small r cube. R equal to 4 into r. Radius will become 64, 4 cube. Next, terminal velocity. So this terminal velocity v, what is v is equal to 9. So okay, 2gr square formula. Density of the liquid by 9 eta. Vt equal to 2gr square 9 eta. This will make density sigma, like this. So Vt by V is equal to R square by R square. Hmm? 160 will come based on viscosity. Next one, optical instrument. There is a compound microscope of lenses having focal length 2 cm, 5 cm and tube length 10 cm. Find the magnitude power in the normal adjustment. What is the method is? The object is kept. O. Image will be formed. Normal adjustment. Final image will be at infinity. For your understanding purpose, I am showing it here. Don't go for exact ray diagram in exam, very problematic. This is a length. This is F naught. This is I and this is eyepiece. Okay, fine. So now this is U naught and this is F naught. And this is V naught. And this is UE. And this is V. V should be infinity. Magnifying power in general for M infinity, this will be V naught by U naught D by FV. Now, practically, what is the V naught? The intermediate image. Is it possible for this eye? This is this eye. Is it possible for this eye to notice this I1? Not visible. What will be visible? Only I2. Object is kept. Image I2 will be visible. I1 will be not visible practically. practically I1 will not be visible. So therefore, what I do is like this image I1 will be so adjusted that it will be near to the eyepiece. Of course, this will be that one. So now this V naught what pen approximately equal to L. And what about you? This object is kept near to the focus. Suppose a focal length is 10 centimeter. This object will be kept at 10.1. So this U naught what you can write F naught. And there's a meaning of normal adjustment. Normal adjustment usually we use for telescope. No, even for microscope also. Final image at infinity, we'll call that as normal adjustment. So therefore this will become V naught approximately L, U naught approximately F naught, M infinity equal to calculate, will get the answer. And this based on optical instruments. In a hydrogen-like ion, ratio of speed of electron in the two orbits is 3/2. Then ratio of energies in these orbits should be. This problem is based on the atoms. Atomic physics. What is the expression for a hydrogen-like ion? Ratio of speed of electrons in two orbits is. So what is the expression for velocity will be? Velocity in the first orbit V naught equal to Z by N. So therefore V1 equal to V naught Z by N1 Z by N2. V1 by V2 N2 by N1. This will be different, no? Like ratio of speed of electrons. Why is that? Z will not be there, no? Okay, this one. Then the ratio of energies in these orbits. Energies, what will write here? E1 equal to minus 13.6 electron volt Z square by N square. E2 equal to minus 13.6 electron volt Z square by N2 square. E1 by E2 is equal to N2 by N1 whole square. N2 by N1 whole square is how much? V1 by V2 whole square. V1 by V2 is how much? Three by 2 is telling. 9 by 4. Atomic physics. Next one. Light waves are incident from a medium of refractive index 2, making an angle theta with normal at a medium of refractance 2 by 3. What will be the value of theta for which reflected and refracted will be perpendicular to each other? I think this is based on the polarization. There's a light wave. This is the refracted wave. This will be the reflected wave. Theta 1, theta 2, theta 1, this is 90. Okay, this is mu1, This is mu2. Polarization. Brevester's law. What is the Brevester's law? Will be you can't derive this in exam. You should know the formula. Or what you should do here? Mu1 sine theta 1 equal to mu2 sine theta 2. Theta 1 plus 90 plus theta 2 equal to 180. So theta 2 equal to 90 minus theta 1. Mu1 sine theta 1 equal to sine of 90 minus theta 1. Mu1 sine theta 1, mu2 cos theta 1. Tan theta 1 equal to mu2 by mu1. Mu2 is how much? 2 root 3 by 2. Root 3. Theta 1 will be 60 degrees. Brevester's law, if you remember directly, you can write this. Or else you have to derive. No, this is based on magnet. A bar magnet is kept such that it is making an angle of 30 degrees with magnet field. The torque acting on bar magnet is 0.6. Find the amount of work done by agent in rotating magnet from the most stable position to most unstable position. What do you mean by most stable position? This is M bar. This is M bar. If external field in this direction and external field in this direction, this is the stable. This is unstable. What do you mean by stable equilibrium? If M bar, what do you mean by, sir, M bar? Dipole, magnetic dipole moment. This is south, north, south, north. The magnet, if the dipole, if the south north is along B bar, stable. If south north is opposite to B bar, then it will be unstable. And they should be opposite. Something went wrong. North, south. Okay, fine. And this is what happens here. Now this will be potential energy U1 equal to minus mb cos 0 degree minus mb. Potential energy mb cos 180. Find the amount of work done by external agent in rotating the magnet from most stable position to most unstable. Work done by external agent equal to U2 minus U1. mb minus of mb. Okay, but we don't know m and b, no? We'll take help of this equation. This is m bar. Then what is the torque acting equal to? mb sine theta. mb by 2. So 0.016. This will become 0.032. Substitute this value. 2 into 0.032. 0.064. This is a work done. Based on magnetism. In ideal gas is closed in rigid content 50 degrees and pressure. The temperature is double. Find the new pressure. I think the gas will undergo isochoric process. Rigid container. When they say rigid, rigid means closed vessel. volume will be constant. The meaning of rigid means volume constant. So P1, T1. The new pressure P2, T2. Volume will remain as it is. Number of moles as it is. So N equal to N. P1 V R T1 equal to P2 V R T2. The new pressure is asking P1 into T2 by T1. Based on isochoric process thermodynamics. We'll take the next one. The density of water at 4 is 20 degrees Celsius. The density of water at 4 degrees is 1000 and at 20 degrees 998. If 4 kg of water is heated from 4 degrees to 20, the change in intensity of the water is. Now, what is being asked here? Something we have to go for calorimetry. This problem is based on the calorimetry. From calorimetry, we have to bring this concept. How to bring all this one? Here we'll assume water like this. We know the density. Density means volume will decrease, no? Temperature will. Okay, fine. Mass will remain same. Density equal to, the density will decrease. Density decrease, density equal to volume will increase. V1, V2, rho 1, rho 2, mass m and m. Temperature T1, 4 degrees Celsius. Temperature 20 degrees Celsius. Here we'll supply Q. Along with this, what are other forces acting? The pressure force. Atmospheric pressure force. Against this atmospheric pressure force, the work has to be done. So what all we supply heat? Delta U plus W. Q is what? Now first we'll calculate the Q equal to ms delta T. A very good problem. You should have the patience to solve. What is Q equal to from calorimetry? Ms delta T. What are the values? Mass is 4 kg. Specific heat of water 4200. Temperature 20 minus 4. 4 into 4200 into 16. Okay, this is the Q. Then what about the work done? Work done equal to P into V2 minus V1. Actually, when you supply heat, this will start expanding against the atmospheric pressure force. So the water has to do work to overcome this atmospheric pressure force. What are these arrows? These arrows are atmospheric pressure force. So now this will become P naught. What is V2 equal to volume? Volume, what we can write? Mass by density. P naught rho 1 minus rho 2 by rho 1 rho 2. Substituting all these values, this work done we have to calculate. You have to do calculation. I'm having 0.8. This is 268268800. Then delta U will be, substitute all the values. Delta U equal to Q minus W. Is it okay? We'll end up this one. This concept okay, why we have to write equation like this? Work done by the water. So I'll write it. Work done by water to expand against atmospheric pressure force based on calorimetry and thermodynamics. In the following configuration charges, find the net dipole moment of the system. Minus 4q. Okay, minus 4q, q. This will become one dipole. This will become another dipole. This is about the effective dipole one. So this will become one dipole. This will become one dipole. P1, P2. So what is P1 is equal to, this length is 2a, 3a. Okay, this will become R1. R1 into 2q. What is P2? P2 is equal to R2 into 2q. R2 will become 4a. R1 equal to 2a whole square plus 3a whole square. Root 13 a. Root 13a 2q or 2 root 13 aq. What about P2? P2 will be 8 aq. Find the net dipole moment is asking now. So this angle theta, we needed cos theta value. Cos theta will be 2a by root 13a. Calculations. They could have given some easier value. Here, this will become one dipole. Minus 2q, 2q. Here minus 2q and 2q. This minus 4q split up in two parts. This length is 2a, this is 3a, this is 2a. So this will become 2a whole square, 4a square plus 9a square. 9 plus 4 will be 13. So a root 13. Cos theta will be 2a by this R1. 2 by root 13. Now the dipole moment, now we'll use the vector form. This will become P1. The resultant dipole moment is given by P is equal to cos theta. What is the cos theta value? Two by 13. P1, P2 values we know it. Solving will get it. This is based on electrostatics. Following are the two lists contains types of electromagnetic waves and list 2 contains their source. Match the following. I think there's a theory here. He has given. Radio waves, microwaves. Microwaves will be due to the oscillating current in antennas. Infrared rays due to odd bodies. Hmm? Fast moving electrons, this from X-rays, fast moving electrons striking this, A will become S. Infrared rays will be P due to odd bodies. X-rays will be due to fast moving electrons striking a metal plate. Next, infrared rays due to the odd bodies and molecules. What we like a when you eat any ordinary body, no, the molecules will vibrate. The vibrating molecule now will its mechanical energy will be converted into electromagnetic wave, and there's the infrared waves. Next, C will be microwaves, will be magnetron. There's a device which will generate microwaves. Radio waves are due to antenna, like mobile antennas, that one. Due to current, a alternating current flows in an antenna will get radio waves. 22. Dimensions analysis, magnetic field intensity, magnetic flux, magnetic permeability, magnetic inductance. I think all is asking simple. First, magnetic field intensity be a magnetic field intensity will become B bar, it should be B bar, B. Okay, what is the different things we can go for? Mu naught value again we don't know. Torque equal to M bar cross B bar. Torque equal to MB. Torque is what? Force M L square T minus 2. This will be current ampere L square into B. This will become M torque will be force into distance L T minus 2. L will not be there. M T minus 2 B minus 1. Magnetic field is asking. The dimensions of this. A will be there, sorry. There's a magnetic field. Magnetic flux B into S will become M T minus 2 A minus 1 area L square. So M L square T minus 2 A1. There's a magnetic flux. Magnetic permeability. Magnetic permeability means mu. Mu is a dimensional one. So for this, what is the best formula you can apply is B equal to mu naught current I by 2R. B magnet B dimensions of B we know A minus 1. Mu or mu naught, both are same. I'm writing mu only. You'll get confused. Current will be A. This will become L. So dimensions of mu will be M L1 T minus 2 A minus 2. Magnetic inductance. What do you mean by magnetic inductance? L inductor. Will be this one. Okay, fine. 23rd. Greater the mass of nucleus, more will be its binding energy. Nucleus with less binding energy per nucleon breaks into nucleus with higher binding energy per nucleon. I think both are true. Theoretical one, I don't have any explanation. Refer it based on nuclear physics. Next, this based on thermal expansion. A brass rod is fixed rigidly at two ends, 27. If it is cool temperature, tension in the rod becomes T naught. Find the temperature at which tension will become 1.4 T naught. Initial temperature 27 degrees Celsius. When it attains the temperature, it wants to decrease length. So force will be like this on the rod. Then we'll go for directly thermal stress. Delta L is equal to L naught alpha delta T. Then strain equal to delta L by L naught alpha delta T. Young's modulus equal to stress by strain. Stress equal to alpha delta T. How you define stress? Force by area. So this will become Y equal to F by A alpha delta T. F equal to YA alpha delta T. So this will become T naught YA alpha, and the temperature will become 43 minus of minus 27. Then how much it will become? 1.4 T naught the new temperature, theta will call it. Okay, this will become minus 71. And this formula you have to apply it. Thermal stress. There's a spring is there. They are cut in the length 3L and L. Total length is L. 4L. Is asking K2, K1. This is K. K equal to YA by 4L. K1 equal to YA by L. K1 equal to 4K. Based on the elasticity. Okay, there's a paper got completed. Okay, kids, now the paper, I think little bit lengthy calculations are there, manageable. This is a typical our JEE mains questions paper, what they're asking. I explained in detail with the diagram, that's why it took more time. Otherwise, you can solve in a very least time. Those are writing 28 shift, all the best. No need to get scared. Just revise all concepts and formulas. Thank you for great support. We'll end up the class.